అమ్మా నేమ్స్ తో లాగిన వాళ్ళు రీనేమ్ చేసుకోండి మీ రోల్ నెంబర్ తో. మీరు కైటా, కైట్ ప్లస్, కైట్ ఉమెన్స్ ఏ బ్రాంచ్ కూడా ఎవరికి అర్థం కావట్లేదు కదా. రీనేమ్ ఆప్షన్ ఉంటుంది చూడండి, చేంజ్ చేసుకోండి అది. సరకు 5 minutes లో జాయిన్ అయిపోతారు.
Good evening, all of you. Is my voice is audible?
Yes, sir. Audio is clear, sir.
Okay. Okay, today we will discuss some of the gate questions, some more gate questions. Data structures and algorithms, and if possible, C++ also. Okay. C language also. Let us solve one problem. So I am giving one gate problem. Identify 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 whether the following are correct search sequences for searching 88. So what this problem is, so I want to identify the following correct search sequence for searching in 88. Searching an 88. So I want to search an element 88. Okay. Let us hear options are. We have some options. A option is we have some sequence I am giving here 10, 100, and 30. Parallelly, you try to do it. When I am writing some option, you try to search for the 88 element. Okay. 50, 90, 60, 95, 45, 75, 88. So this is a one sequence. 10, 100, 30, 50, 90, 60, 95, 45, 75, 88. So this is option A. Coming to option B, 11, 110, 21, 91, 51, 71, 81, 85, 88. And option C, is 3, 333, 83, 89, 73, 85, 88. So this is option B. Seven, 17, 77, 177, 57, 87, 88. So these are the some sequences. That means, so now what is the searching sequence we need to follow is we need to see that it is a binary search actually. Okay, so binary. Binary search. So now let us discuss this one. Okay. Now tell me if anyone is just completed this problem. Now which option is a correct option? Or now what is this intention of this problem is? Now I need to use the binary search. I'm using a binary search tree. So I need to complete like this. Okay. So we have some 4 options. Which of the following search sequence is correct search sequence? Which of the following is correct search sequence? Just try to search element. What is the element I need to search here? 88 I need to search. So that means if I need to search 88, so which element is it's a violation or correct search sequence, you tell me. This is one of the gate question, previous gate question, and it is also a very important thing. So here, which of the following is a maybe correct or wrong search sequence? Okay, sometimes he will give you correct or wrong sequence. That means whenever he will give that a correct or wrong sequence means here you need to observe here. Or suppose they might give you correct or wrong sequence. That means based on options, we need to search. Based on options, we have to decide. That means if the three options are right and one option is wrong, then we have to pick up that option. Okay. Otherwise, it's a reverse process. So vice versa. So that means either all are wrong sequence, one option is correct, then we can how to choose that correct option. So like this, you need to select. Okay, let us see that the first sequence. Anyone completed this problem? Okay. First of all, at least I am trying to explain with the first option A. So 10. Let us take it is I am trying to search 10. Okay, good. So I need to start from the 10. So in binary search, we know that whenever you are searching a binary search, so what is the searching of binary search here? The right hand side element is greater. Suppose the sequence he has given just sequence. So 10 is 10. After 10, what is the element it is being getting? I'm getting element is 100. That means 10 is greater than 100. That's okay. And next element after 100, what is the element? So it is a 30. So 30. 30 is 30. So because this is a search sequence, I'm not inserting into a tree. I'm just search sequence. Okay. So let us take this one and 30 is inserted here less than 100. Okay. So that means this search sequence is also correct. 30. I don't have any issue. And whenever you are like searching an element, you see here 10 is greater than 10 is actually greater than. So that means 100 is greater than 10. So that's why we keep right side. And 30 is less than the 30. And overall, you see that overall it is a greater than 10 only. Overall right hand side part is should be greater than 10. That's okay. Next, 50. What is a 50 element? 50 is greater than 30. Greater than 30 means what it is? Greater than 30, like this 50. And after that, again 90. 90. Whenever you are searching this sequence, it should not violate any of this condition. What is a violation of the any of condition means? That means the element which is you see here 10, you are searching 100. That means like this, it should be greater than 10. All the elements should be greater than 10. And you see here 100, I come here left side. Whenever you come the left hand side, the all elements should be less than 100. Less than the 100. And whenever you're taking this decision, 30 is greater than 50. That means 30 is greater than 50. Whatever the elements should be greater than the 30. So like this, you need to check it. So till now, we don't have any violation. It's a successful search only. It's a search sequence. Next, 90. So next after 50, it's a 90. So 90 is also, so we can place here. So we can place here what is 90. Now it's okay. I don't have any issue. Still, it is satisfied. Next, after 90, now again, we are in next search sequence is 60. You see that 60. 60 means it should be less than the 90. Less than the 90. Less than the 90. So that means it is less than the 90. 60 means. Okay. Next, what is a element that is present? 95. So 95 is, you see here, 95. What is the search sequence here? 60 is greater than, yeah, 95 means it has to place right hand side of the 60. So it is 95. But you see here, this is a violation actually. You see here 95 is not satisfying because, so this 95, you see here less than 90 means 60, okay. But is 95 is whatever the left hand side part of everything should be less than the 90. But you see here what is the element I am searching? 95. So less than 90. Is it 95 is less than 90? No, it is a greater than 95. So this is a wrong search sequence. This is called as a, no, this option is wrong search sequence. Wrong search sequence. Here the 95 is violated. What is the element that is violated here? The violation condition. Sometimes they will ask you that what is the element that is violated of the binary search when you are searching an element. 88. So this 95 is here only eliminate that's violated the basic rule of binary search tree. So that means this is a wrong search sequence. This is called wrong search sequence. Okay. Now come to B. What is B here? So how this B is adding here? And whatever, so whatever I did A option, now you people try to do for the B, C, D. So, and check B, C, D. Those B, C, D options are wrong search sequences or right correct search sequence. You try to search. Just work out and tell me. Just take 2 minutes and tell me, all of you. Work out and tell me. What about B option? And what about C option? And what about the D option? Those are correct search sequences or wrong search sequences? I want to know. So you do parallelly. So meanwhile, I will do, I'm going to do one more option. So option B, I'm trying to search. I will explain you one more option. This is option A. This is option A. And now I will do one more option is B. So now tell me what is option B. So first is 11. First element is 11 in option B. I'm saying 11. Next element is 111. 111 means it's a greater than 11. I can place here 111. And after that, less than. So that means what is the element? It is a less than, that is a 21. So I don't have any issue. You see here, whenever you are searching like this, 11 is greater than, so here 111 is greater than 11 as well as 21. 21 is less than 111 as well as you need to check the root node also. It is a greater than greater than or not? Greater than 11 or not? Yes, it's a greater than 11 only. So we don't have any issue. So like this, you need to search for the starting onwards. Again 21. 21 after that again 91. 21 after 91. Now you see here 91 is greater than the 21 is greater than the 21 greater than the 21. 91 is greater than 21 as well as less than 111 as well as greater than 11. So all conditions are satisfied. And similarly, you search for the now after 91. So again 51. Now you see here 51. So that means 51. It should be less than. Now what is the element here? It is 51. Now what about this 51 search sequence? So it is a greater than 11. It's a less than 111 as well as it's a greater than 21 and also it's a less than 91. So all conditions are satisfied. We don't have any issue. Next is 71. Now you search for the 71. You see here 71 should be greater than 51. Should be greater than 15. 71 is greater than 51 and less than 91 and greater than 21. And you search here less than 111 and it's a greater than 111. So all conditions are satisfied. Again 81. Now you search here 81. So 81 means 81. This is 81 and it's a greater than 71. So I can place here 81. And when we are searching like this, you can see here it's a greater than 51, it's a less than 91 because it's a left side part. Okay. And it's a greater than 21. So it's a less than 111, it's a greater than 11. So we don't have any issue. Next 8. So like this, we don't have any issues here. Okay. So it's a greater than means it's a right side part. 81, 88, sorry, 85 first. 85 and after that 88. So this is correct search sequence. 88, 85 means it's a here 88. Now see here. This is the correct search sequence only because we don't have any issue. Here actually this condition is violated. 90 is actually it's not less than 95. So this is our actually this is violated. But here you see, so everything is satisfied. So this is option B. Okay, option B is what? Option B is correct search sequence only. Say correct search sequence. So let us search for the option C. Similarly, what about option C? Can anyone tell me? Completed or not? Can anyone tell me just what about the search sequence of C? Whether it's a correct search sequence or wrong search sequence? It's a wrong. Very good. So which is a node that is violated actually? So wrong means you need to tell that some node should be violated. What is that node? 73. Very good. So very good. 73 is violated. For option C, it is a 73. Similarly, DMA. So here 73 is violated. This is a wrong search sequence. Good. And what about the D option? Option D is option D is 77. No. What is the problem with the 77? No, once check it. Wrong only, but okay. Quickly I will do it. Okay. So for option C, option C. So all of you do it, please. Just only it's not I always tell you it's not one side. Yes, okay, very good one. It's a 57. Option D is wrong sequence. And what is that it is violated? It is 57. Excellent. So the violated condition is here 57. Okay, anyway, once I will deal these two options also. Okay. So let us quickly. 3, option 3, here, sorry, 3 and greater than option C I am dealing. 333, no issue. Again, 33, 33. 33 is less than 333. It's a less than 333, no issue. Okay. So, and also greater than 3. 33 is greater than 3 as well as less than 33. Next, 83. So, 83 is greater than 83. Next, say greater than 89. Next, say sequence is 89. We don't have any issues till now because 88 and 83 are, you see, greater than 33 as well as less than 333 as well as greater than 3. Greater than the 3. So we don't have any issue till now. Sorry, not 88, it is 89. Okay. 83 after. Okay. 83 after 89. Next, 73. Now 73 is 73 is less than the, you see here, I should place here where less than the 89. Less than the 89 means what is that? It's a 73. But what is the problem? It is not greater than 83. So this condition is violated. It's a less than 89, that's okay. But it is not greater than the 83. The 73 is not greater than the 83. So here the condition is failed. So this is the wrong search sequence. This is a C option also, wrong search sequence. So wrong search sequence. And final option D. Option D is option D. Option D is 7. Option D is here 7. 7 is Next option is 70, 17. So it's a greater than 7. It's a greater than 7. And 77. 77. 77 is also, say, greater than, we don't have any issue. So 77. It's a greater than 7 as well as a greater than 17. Okay. Next 177. Perfectly all right. So which is, we don't have any issue because this 177 is greater than 7, greater than 17, greater than 7. And is a 177. And finally 57. So 57 is actually, it's a less than. Here I need to search sequence less than 177. That means 57 I have placed here, but problem is, here you see here 77 is actually 177 is greater than 77, but you see 57 is not greater than the 77. So here the condition is violated. So here the condition is violated. So this is also option D also wrong. Wrong search sequence. So finally, what is the correct option? 3 options are wrong search sequences. 1 option is correct search sequence. So the option is B is the correct option. B is the correct option for this question. So like this, you need to search and identify the tree. Okay. So this is one of the very important one. And any doubts regarding this question? Okay, right. So next we will go for one more gate question. Okay. Meanwhile, if you have any doubt, you can ask. Otherwise, you can write. Okay. Next very interesting question actually. So this is from the they have a actually from the recursion actually. Okay. So in the gate actually, so the recursion actually one of the very important concept. So we will get one of the question, guarantee question. So here I'm taking that question. So binary search. Okay, let us take okay, before the recursion, there is actually one more interesting question. Anyway, we have touched the binary search tree. So from that, we may get one more possible question is, and already one of the previous questions simply. So this is I'm just giving one tree. The given tree is very simple binary search tree I'm giving. This is of 40, 20, and 60, 10, 30, 50, 70. This is a tree actually. Now tell me I'm going to delete some node 40. Actually, a node 40 deleted from the given tree. What will be deleted from the given tree. Now, a node 40 will be deleted from the given tree. So what is the node we can keep as a new root node? This is one of the question. Okay. So option A is 20 and option B is 60. Option C is 30 and option D is none of the above. None. So tell me. So I have deleted the node. It's a binary search tree. Okay. It's a binary search tree. I have deleted the node 40. So which node will be actually replaced as a new root node? So very good. So some people have given 30. Okay. So what is the reason for the 30? Because whenever you node, the node will be deleted. So the new node is actually either in order predecessor or in order successor has to replace. So that means in the left hand side and the maximum element is you come to the in order predecessor, come to the left and search for the minimum maximum element. So that's why 30 will be one chance, and come to the right hand side and search for the least element. So then the right hand side, what is the least element? 50, either 30 or 50. So here option is actually C option is there. So we can say that option C is correct option. Okay, very good. And one more thing is, okay, so like this, you see here. And what is the time complexity of, best case time complexity of the binary search tree for searching? Okay. What is the best case time complexity and what is the worst case time complexity? Tell me. What is the best case generally? Because anyway, we are discussing this one, best case and worst case time complexity. What is the best case as well as worst case? Worst case is first tree is n. This is a disadvantage of the binary search tree also. Okay. Worst case is n, because if it is a left skewed or right skewed, we have to search all the elements. Suppose if the elements are 10, 20, 30, 40, 60, like this is there, we need to keep on going, right? So in order to search for the 100, we need to search all the n elements. So either left skewed tree or right skewed tree. If the tree is like a left skewed or right skewed, so we need to search all the elements. So that's why worst case time complexity is order of n. Order of n. Because it's taking worst case. And what is the best case time complexity? What is the best case? For searching only. I'm just asking you that only searching. So what is the best case and time complexity, and what is that case also? You try to tell me. Suppose whatever I want to search an element, if it is present in the root node, what is the case? Suppose I want to search 40. So how much time it is taking? How much time it is taking if I want to search 40? It is taking order of 1. It is taking order of 1. So searching. So like this, we need to apply the elements. Next, one more question we will go. For left skewed or right skewed, it will take n time complexity. Okay. Example like this, it is there. Okay. Left skewed means right skewed 10. 10 is 20, 30, 40, like this 50, like this 100. Suppose you want to search, it's a called right skewed tree. That means if I want to search 100 element, it will take what? N. All the n elements you need to come and search it. So finally you will get your answer. That means it is the worst case, it is taking order of n time. Like this, you have to analyze the time complexity for any problem. Okay. Okay, let us one more question we will go for. What is that? One more question, actually very important one. So one of the previous gate question, because what definitely they will give you one recursion type actually. Okay, because in the GATE syllabus, they have mentioned recursion. So that recursion problem is very important. So let us, I'm writing you here. It's a very simple code here. Why we are having some function, this function int x, okay, int x, and where we have a void function. Okay, just concentrate on logic here. If x is greater than 0, so whenever you are applying recursion, the initial conditions we need to check here. Initial condition is very important. Whenever x is greater than 0, whenever x is greater than 0, x is greater than 0, and one more function, one more here. If x is greater than 0, we need to call the function recursively. We need to call the function recursively. So that is function in the function x minus 1. Function x minus 1. Like this has to be repeated actually. Okay. X minus 1. And some printf statement. We'll write here. Printf. So printf of x. Okay, I'm printing of x. And again calling same function of same x minus 1. X minus 1. So this is very simple code. So I am just closing this if condition as well as the main condition also I am closing. Okay. So here I want to calculate. Here I am trying to calculate void main function is there. So this main function, void main function is there. And I am trying to call here functions. What is here? Function of 3. Function of 3. What is the output? What is the output of this program? Option A. Actually, it is a recursion type. Okay. This is also one very important option A. We have some options here. So I'm reading this problem again. Void function in text here. We don't have any syntax errors. I'm trying to clear here. So void function, and if x is greater than 0, we are just calling function x minus 1 and printf x. I'm just writing in a shortcut actually. Okay, printf x and function x minus 1. So this is what function, and here the calling function void main function 3. So now what is the options? Coming to option A, what is our answer? What is option B? Option A, I'm giving some options also. Option A is 1, 2, 1. Next. Option B is 1, 2, 1, 3, 1, 2, 1. Option C is 1, 2, 1, 1, 2, 1. Option D is 2, 1, 1, 2, 1. Option D is none. So how to solve this type of problems, recursion problems? So what we need to do this recursion type of problems. Whenever we are getting a recursion type of problems, so this is purely recursion type. Okay, it's a purely recursion. We have a some function, and if it is greater than 0, I'm calling function 3 actually. Okay, so can anyone just try and tell me? Otherwise, I will tell you. Don't worry. Okay, and how to solve these type of problems in the gate easily. Anyone completed? And tell me which is the correct option. Okay. Okay. Otherwise, I will explain you without wasting time. So we have a f. We have a some functions here. F of 3. So first one is what? We are calling f of 3, right? Function. I'm writing in a shortcut, okay? F of 3. F of 3. This is the function I'm calling. And in this f of 3, so first, when the function is calling if x 3, when I'm passing this here, void, it is a 3. Okay. X value is 3. Is 3 is greater than 0 true or false? It's a true. True means we need to continue this one. Okay, what is that function? So that means it is calling f of 2. Yes or no? It's a f of 2. I'm writing in a shortcut, okay? F of 2. And again, printing some statement. Okay. So we have some printf statement. In the middle, we can print the dot statement. So in the second, because I'm just writing recursive, like this, you need to draw the diagram. So it is again f of 3, f of 2, f of 2. Here, what I am trying to print? Here I am printing 3 actually. Okay. Here printf of what? What is the value of 3? So it's in the past of this is a 1. Okay. Whenever if it is this condition is failed, then we can say we can close this if condition. Only we have a simple if condition here. Okay. In the if condition, there are 3 statements. Function 2. So now function 2 means what again? It is recursively calling one more function. That means again here we have again function 2 like this. We have a again there is a function 2 means it will be f of again calling same function. It is a greater than 0. That means what? F of 1. and we are printing. What is the printf statement means here? 2. 2 will be printed. And again, f of 1. Again, this f of 1 means recursively calling again. So what is this recursively calling here? F of 1, again we have a recursive type. So that means f of 0. That means whenever x is greater than 0, we need to repeat. If 0 is greater than 0, condition is failed and we have to stop. Here in this printf statement, what is printed here? 1 is printed. And here again f of 0. I'm just writing in a shortcut, okay? F of 0 to Zola, because writing is taking much time. Okay, next. Here anyway printf statement 2 is there. Again f of 1 means what? Again f of 1 means, so same thing it is repeated. So here f of 0, here printing 1, and here also f of 0. And we have printed 3 here. And this f2 means again the same tree will be repeated. Here, this f2 means here also the same tree will be repeated. Here also the same tree will be repeated. That's what, right? This way you will to solve the recursion. Okay. Now what is the output? What is the output of this program here? Now 1. Here this is the printf statement is what? 1, 2, 1, 2, again 1, again 3 here. And in this tree, what it will get printed again? F of 2 means same thing, right? What is the same thing means? 1, 2, 3. 1, oh, sorry, 1, 2, 1. So which option is correct? So the final answer is this is 1, 2, 1, 3 followed by 1, 2, 1. Which option is correct? 1, 2, 1. Okay. 1, 2, 1. Okay, here printing machine. Just I just print. Say 1, 2, 1. 1, 2, 1. Here 1, 2, 1. 3, 1, 2, 1. Option B is correct. Option B is correct. I'm just read it. 1, 2, 1, 3, 1, 2, 1. So option B is correct option for this type of recursion. Okay. Whenever this recursion type of problems are coming, draw tree like this. Then only you can get answers easily. Okay. Otherwise, there is a chance of doing mistakes in the recursion. So this is the one more question. So one more. Any doubts in this one? So like this, you can draw the tree. So you can get any question. Next. It's a simple recursion. Next, one more. So if you write this one, I will go for the next problem. Okay, let us go for one more problem. Gate question, one more gate question. Let us take T of n is one problem using time complexities. They have given one recurrence relation is T of n is equal to T of n equal to 2t n by 2 2t n by 2 plus square root of n plus square root of n. This is a given recurrence relation. This is a given recurrence relation they have given. Now I need time complexity of this recurrence relation. Time complexity of this recurrence relation. Okay. Option A. Option A is log n, order of log n. I'm not writing that. Okay. Next, option B. Option B is n. Next, option C is square root of n. Option C is square root of n. Next, option D. Option D is n log n. N log n. So tell me which option is correct, and because this is a gate question, right? So we cannot spend much time actually. We need to give the answer within 1 or 2 minutes only. We can also very important. Time constraint also very important in gate. This is a given recurrence relation. They have given the recurrence. They are asking that what is the time complexity of this recurrence relation. Okay. So basically, we have a different methods for solving recurrence relation. Substitution method we can do, forward substitution, backward substitution, and we can apply the these are the two common approaches. And also, if you see like a discrete mathematics way, we can find out the is using generating functions we can find, and you can find out the roots of the using the characteristic roots method we can find. These are all time consuming processes actually. So these all methods are time consuming. But this type of recurrence, whenever the recurrence relation is like this, okay? Whenever this recurrence relation is like this, that means it is in the form of A T of n by 2 n by b, not n by b format. So whenever this is in the form of stuff like this, okay, we have some shortcuts here. So whenever the recurrence relation is one, and in this one any function, okay, it may be n or f of n or anything, some function, okay, some function. How we need to tell you this, find out the recurrence relation easily is Here, what are the A and B values? Here, A value is the 2 and B value is a 2. So the shortcut is using master theorem. Actually, this problem we can solve using master theorem. Master theorem, because we don't have much time. I will tell you that very shortcut. Okay, how do you find out using master theorem? Okay, so this master theorem we have a 3 cases again. Okay, so just to find the n power log n power log a n power log a base b, log a and base b formula. You need to find out n power log a base b. That means what? N power, what is the a value here? A value is in the given reconciliation. What is the a value? A value is equal to 2 and b value is equal to 2. So I can say that n power log so here upper here a means 2 and b is also 2. Now totally overall b is also 2. Now tell me here n power log 2. What is the answer here? N power log 2 means, what is the log 2 value? Please respond for this. What is the log 2 value means? So whenever here log 2, that means base as well as the power is same, it will be 1. That means what? N power 1. So here option n power 1. So that means this n we need to compare with this f of n. So what we got? So is n is greater than the f of n. Greater than f of n means what? Greater than the square root of n. So n is greater than the square root of n or not? Whenever it is n is greater than the square root of n, that means f of n. So we can say that this n will become the time complexity. This n will become the time complexity. So it's the time complexity of this recurrence relation is simply order of n. The time complexity of this recurrence relation is order of n. So this is option B is the correct option. Without solving, using characteristic rules, forward substitution or backward substitution, without using the solve method, this is a shortcut. Using master theorem, we can apply. So suppose if I got n square and f of n is only n, then answer is n square, square root of n. Suppose you got here n and already there is and already f of n is actually n square. Suppose second case, already this is we find n, but f of n is here n square. So if n square is greater than, then we can say the time complexity of this. So like this you need to take. Suppose if both are same, third case is if both are same, this is also n and this is also n. So if both are same, this and n and whatever way this f of n is n, then answer is n log n. These are all the 3 cases in the shortcut, n log n. Okay. So this is actually basic master theorem. Okay. First case is whatever we have find n power log a base b is greater than the f of n, So if you want to, you can write, okay, all the three rules. So first rule is what? N power log A base B. If it is n power log A base B is greater. N power log A base B is greater than, then we can find the greater than the f of n. Greater than the f of n. And one more case is what? Same. N power log A base B is greater than the f of n. Is greater than the f of n. This is the second case. And what is the third case? If it is equal, suppose n power log A, here luckily we got a case 1 actually, okay, in this problem. Log A base B is equal to the f of n. F of n means this area, the square root of n or something. In this problem, they have given square root of n, or some problems they will give you n square, n cube. Like this, they can give you is equal to f of n. Then these are the three cases in the master theorem. Okay? First case is if it is greater than means the answer is n power log A base B only. First case, this is the answer. If it is the second case, n power log A base B is less than the f of n, then f of n will be the answer directly. If both are equal, n power log A base B and f of n is equal, then not n log n, here whatever there is a n power log A base B, f of n are both are same, right? Then f of n into, okay, f of n into f of n into log n. Maybe it's not always n log n. F of n may be n square log n. If f of n equal to n cube, then n cube log n. Like this, we need to add f of n into answer log n. So this is the answer if both are equal. So apply this shortcut for any problem, you will get it. But what is the basic condition? It should be in the form of like this. A T n by B plus f of n format only. Remaining formats, you have to apply the either substitution method only. We don't have any shortcut for that. Okay. This is a shortcut for only this type of, if the recurrence relation is in the form of T of n, A T n by B plus f of n, then we need to apply this technique. Clear? So let us take a let us take one more problem. One more simple problem. So in the match the following type of questions also they will give you. They will give you 2 or 3 recurrence relations, and they will ask you time complexities of these recurrence relations. Okay. So at that time, be careful. Okay. So let us, okay, we can apply one more problem based on this so that you will get confident. Okay. Now, T of n equal to T of n equal to T of n equal to n by 2 to 2t n by 2 2t n by 2 2t n by 2, and we can close this parenthesis. Plus, what is f of n? F of n equal to f of n equal to n. F of n equal to, let us take value n. Now solve this recurrence relation and tell me the answer. Option A, and option B, option B is n square. Option B is n square. Option C is n log n. Option D is none. So tell me which option is correct. What is the correct option? Tell me. Solve the above recurrence relation and tell me what is the correct option. In one of the previous gate question, they have given match the following. That means left hand side they have given some recurrence relation, right hand side they are giving time complexes. Tell me someone what is the correct option for this one. What is the correct option? Here we need to find out the, again I am repeating here, n power log a base b. What is the formula? N power log a base b. N power log a base b. Log n power log a base b. N power log a base b means what is the a value? What is the b value here? What is the a value here? A equal to 2, b equal to 2. So n power log 2 here also log 2. So what is n power log 2? Log 2 means it's a n power 1. So both are equal, right? N, which is equal to f of n, which is equal to f of n. F of n value is how much? F of n value is n. So if both are n, so if both are n, then what is the correct option? Is C. Option C is correct option. N log n. If f of n as well as n log n are both the same, n into log n. That means f of n into log n. So this is option C is correct option. Option C is correct option. N log n. So like this, you can solve any number of problems. So similarly, we'll take one more problem. Any doubts in this one? So here I'm giving here, instead of this 2, I'm just changing this question only without wasting time. Instead of this 2, I'm writing in place of 2, I'm trying to write here, it's 4. It's 4. 4tn by 2 plus n. Now tell me which option is correct. Now I just changed this one. I changed the recurrence relation. Previously it is a 2tn by 2 plus n. Now I have changed 4tn by 2 plus n. So for this, what is the correct answer we will get? Can anyone just give me reply? T of n equal to 4tn by 2. This is a given recurrence relation. Now tell me what is the correct option? What is the correct option here? What's the time complexity of that problem? Just take 2 minutes and try to solve it and tell me, give me the reply. Options are both same. Okay, A is n, B is n square, C is n log n, D is n none option. Okay, so which option is correct? For solving this type of DA algorithm questions, actually we need some basic mathematical knowledge also. Because logarithm, what is a log like this, we need to know that. Very good. Someone has given reply. So it's correct answer. N square. Very good. N square is correct. So it's very simple. Log n power n power. What is the A value? A value is 4. B value is 2. So what is this? N log log A base B. That means 4 I can write as the 2. 2 square. 2 square means what? It becomes n power 2 square. How you will write? N power 2 log 2 as well as here base is already 2. So log 2 means it becomes 1. So the answer is n square. So n square is the this value, and we need to compare this function with the f of n. What is f of n value? So f of n value is n. So which is greater? So n square is greater. So the option is B option. Correct option is B option, because it's a n square. Suppose in the place of here f of n, there is n cube is there. Now same problem, n cube is there. Now what is the answer? In place of f of n, there is a n cube is there. So n cube will become the answer. Okay. So option here in the none option, there is a n cube. If f of n is like n cube is the answer. Like this, you can solve any of the question if it is in the form of standard format. Just apply this one. Okay. So one more very interesting question in the previous gate question is, actually I'm covering all the three all the topics actually. Okay. So that because anyway gate exam is so I think for some people first is there CSC. So let us see that one question. I hope you understand this concept. Now we will go for one more question is, I'm just writing int. Here I'm giving some recursion only. Int again, it's a recursion type only. So you tell me. Int x, int x, int x, and flower bracket open. And same if n is greater than 3. If n is if n is if n is greater than 3. If n is greater than 3, we can apply. If n is greater than 3, return 1. Sorry, it's less than 3. If n is less than 3, n is less than 3, we can return 1. Return 1. Else return x of n minus 1, x of n minus 1 plus x of n minus 1 plus x of n minus 3, x of n minus 3, n minus 3 plus 1. I already explained no previous problem. Try to draw the tree so that it will becomes very easy. Now I want the question is total number of invocations present in this program. Total number of invocations. That is what I want to know that. I will give you a number also. Total number of invocations total number of invocations. Total number of invocations of x of 5. If you solve this question, you can solve any of these questions. Okay, this is the most tricky question. Okay, x of 5. So total number of invocations present in the x of 5. Option A. Invocations means what is invocations means? Function callings. Okay. Here, option A. So we will give you some options here. Option A 22. Option B. Option B is 17. And option C is 15. And option D is 24. Tell me, total number of invocations present in the x of 5. Okay. So solve first x of 5. Okay. We'll solve first x of 5. Now tell me x of 5. First x of 5 means what is 5 is 5 is less than 3. Is written 1? No. If 5 is not less than 3, so we will go for the else case. In the else case, what is, can anyone parallelly tell me if you know answer? You try to answer it, okay? Here, x of n minus 1 plus x of n minus 3. What is x of n minus 1 means here? X of 5 minus 1. 5 minus 1 means x of 4, right? X of 4. And here, x of n minus 3. N minus 3 means 5 minus 3. That means what? X of 2 plus 1. Okay. Plus 1. Plus 1. Okay. X of 2. So like this. This is the factor. Okay. X of 4. That means x of 2 plus 1. So this is one invocation. Okay. This is one invocation and this is one invocation. And this is one invocation x of. So I'm asking total number of invocations. Suppose for x4. So x4 you tell me. X4. So same. N is the 4 and 3. It's not true. It will come to the else case. So if you come to the else case, x of n minus 1. That means x of 3. X of 3 plus x of 4 minus 3. That means what? X of 1. X of 1 plus 1. X of 1 plus 1 plus 1. Okay. So now x of 1 means what? Return. If 1 is less than 3 means it will be written 1. So we are just returning to 1. We are writing 1. So now x of 3 again is 3 is, what is here? Is n is 3. Still it is else case only. Okay. So we can x of 3 means x of 2, x of 2, x of 2, x of 2 plus 3 minus 3. X of 2 here, x of 3 minus 3. That means x of 0. X of 0. X of 0 plus 1. So, like this, okay? X of 4. X of 4, how many invocations? X of 3 is how many invocations? Is getting 1, 2, 3. There is a 3 invocations are there. X of 3 means, okay? And similarly, for in order to calculate x of 4, how many invocations are involved? In order to calculate. So these 3 invocations and these 3 invocations and this x of 1. This will be 4 and this x of 5. So x of 4, how many invocations are there? 5 invocations. 5 invocations are present while calculating x of 4. While calculating x of 3, there are 3 invocations. Try to see here. While calculating x of 5 total, x of 5, these 5 invocations, in order to calculate 4, 5 invocations, and x of 2, 6, x of 5, 7. So total number of invocations to required for the x of 5 is 7 invocations. 7 invocations for the x of 5. Invocations means nothing is there, only function callings. Okay, how many function callings are there? So in order to calculate x of 5, total number of invocations are required is 7. Total number of invocations are 7. Now here, I want to calculate x of 5. X of 5 means now x of 5 is how much we got? 7. So x of 5 means x of 7. Again, x of 7 I need to calculate. So same thing, x of 7 means, tell me, x of 7 means. So again, it is 7 is greater than 3. So that means x of 7. Anyone completed? Answer. X of 7. X of 7 means what is? X of 6. X of 6 plus x of 7 minus 3. What is x of 4? X of 4. 7 minus 3. X of 4 plus x of 4 plus 1. So what is x of 3? Again, x of 3 means again we need to find. So what is x of 3? 3 minus say 6 minus 1. So it's a x of 5. X of 5. X of 5. And it is a 6 minus 3. X of 3. X of 3 plus 1. This is a constant. It is not an invocation. Okay. Plus 1 means. So like this. Now you no need to again do it. We know very well. X of 5 means how many invocations are required? This is x of 3. So x of 5 means how many invocations will be required in order to calculate x of 5? 7 invocations. Okay, very good. 7 invocations for x of 5. Similarly, x of 3, how many invocations? For x of 3. We already calculated here. X of 3, 3 invocations. 3 invocations. X of 3 will require 3 invocations. Okay. So 10. So for the total x of 6, how many invocations will require? 7 plus 3, 10, including x6. So total 11 invocations will be for x6. X6, total 11 invocations. Total 11 invocations are there. For x of 4, how many invocations are required? In previously we have solved, you see here. X of 4, 5 invocations will require. So x of 4, 5 invocations will require. So 5. So total 11 plus 5, 16, including x7. So total for calculating x of 7, how many invocations will require? 11 plus 5, 16 plus 1, 17 invocations will require for the x of 7 for calculating x of 7. For calculating x of 7, total 17 invocations will require. Okay, but what we want to calculate x of 5. That means for calculating x of 5, 7 invocations are there. So total how many invocations? 7 plus 17. Most of the people will confuse and they will answer it 17 only. No. So what you need to give? So total, because x of 5, in order to calculate x of 5, we require 7 invocations. Now x of 5 is already 7, x of 17. So that means x of 7 means, again total for calculating x of 7, 17 invocations. So total number of invocations, how many? 7. These invocations are 7 plus this 17 invocations. Okay. So total 20, 17 plus 7, 24. 24 invocations will be required to calculate x of 5. So this is very important one. Okay. So total option D is the correct option. Okay. So if you have any questions, you please try to utilize. Like this, the gate questions we need to answer very carefully. So if you apply the concept, it becomes very easy. So tell me if you have any doubts till now, you can ask me. I will give you 5 minutes of time. You try to just see that. If you have any questions regarding the GATE exam or the subject or anything, you can ask. If you have any queries, if you feel free to ask. Otherwise, we will try to close the session. So I will just wait 5 minutes. If you have any queries, you just type or I will unmute you. You can ask lots of things. Any queries? Okay, like this, in a DAR, you can see that recurrence relations and try to analyze the problems, all the problems, divide and conquer and greedy approach problems. Yeah, I already revised in the previous classes all the problems we have discussed, and you try to analyze the problems and try to find out the time complexities and try to solve those problems. Okay. Okay. So if you don't have any queries, I will just leave. Okay. Sir, can we close the session? Okay, right. I'll say next class.